Hello everybody and welcome to this Easy 11 Plus live lesson on pie charts. Please remember to subscribe to my channel and to check out the free resources linked in the video description, and don't forget that the worksheet for this week's lesson, as always, is linked in the video description. Let's get started. So here we have a typical pie chart question. And you're probably familiar with what pie charts are, but if you aren't, they're just a way of showing information in a proportional way. So for example, if we look at this pie chart, we can see that half of the children picked hockey as their favourite sport, because we can see that half of the pie chart is taken up by the section denoting hockey. And there are a couple of really important things to remember when you deal with a pie chart. One of them is that there are how many degrees in a circle? 360, of course. Don't make the common mistake of thinking that there are 365 degrees in a circle. That's the number of days in a normal year. You'd be amazed how many people get confused by that when they're under exam pressure. So there are 360 degrees in a circle all the way around, something I've spoken about in lots of my other videos. And so for example, hockey here, taking up half the circle, covers an angle of 180 degrees. The other important thing to remember is that the pie chart shows all of the items that we're looking at, in this case all of the 120 children. So this shows 120 children, but it also shows 100% of the children. 100%. There are some people saying that the stream isn't working in the comments here. Hopefully if you're seeing this, it's because it is working for you. I had to start the stream and stop it and start again because I had some trouble with my simultaneous stream to Facebook, but I hope it's okay for everybody now. Okay, so back into this. Right, so they're the key things that we need to focus on. If you continue to have problems with lots of buffering and so on, let me know. There might be something that I can change to improve that. So the first question says, what percentage liked netball? So it looks like a quarter of this pie chart is for people who pick netball, and a quarter of 100% is of course 25%. Now, you may note that there's no symbol here to show us that this is a right angle. So what happens if this actually is an angle of 95 degrees, for example, rather than 90 degrees? It's very hard to tell. So in an exam, if you've got one of these, a protractor, you should use it at this point just to check that this really is a right angle. And I've done that already, it is. So the answer here is of course 25%, which is a quarter of 100%, or all the way round. Okay, I'm just going to make a quick change in the background because people are saying that they can't see properly. I hope that improves things, and I'm just going to turn something else off. Closing web browsers in the background. It could be my internet connection is getting overwhelmed. Okay, back into things. What fraction, like fraction, I sound like Jonathan Ross, what fraction liked rounders? So liked must be referring to the favourite sport that they've picked. It isn't very precise wording. It's possible that someone said that their favourite sport was rounders, but they also liked netball, but we aren't given that information, so we just have to go with it. What fraction liked rounders? Make this a bit smaller so we can see it. Well, so looking at this, I'm going to tell you that I've measured this and this already, and they are indeed 45 degrees. In an exam, again, as I mentioned, you should get your protractor out and check that those angles really are 45 degrees, so half of a right angle as they appear to be. That being the case, each of these is half of a quarter, and half of a quarter is an eighth. You can also check it like this. You can just extend the lines out like that and see what we've got. We've got 1, 2, 3, 4, 5, 6, 7, 8 sections of the circle, and rounders represents one of them. So it's clearly 1/8. That's quite easy, but it's worth explaining it for anybody who isn't completely clear about it. How many liked tennis? Okay, not how many degrees, how many children. So let's go back into this. How many of these children like tennis? So 1/8 of the children like tennis. We've already worked that out. It's the same as for rounders. And there are 120 children all in all. Okay? So we've got 120 children and 1/8 of them like tennis. 1/8 of 120. So we need to do 120 divided by 8, which is the same as 60 divided by 4. It's often worth simplifying down just to get to the answer nice and easily without too much mental effort. Equals, oops, what am I doing? I'm skipping to the answer in an absurd, nonsensical, non-mathematical way. Equals 15, that's what I mean. So how many like tennis? 15 children like tennis. It's 1/8 of the total, which is 120. Never neglect to look back carefully at the information you're given, because that's where you find out about the total number of children. People saying they have buffering and stopping problems. I'm very sorry if that's the case. At this point, there's nothing more that I can do about that. I hope it sorts itself out for you. The contents of part of a wardrobe are shown in the pie chart below. And this one's different because here we're given the percentages. And we know that the whole thing will show 100%. You can check that if you want by adding these up. And so each of these is the percentage, the fraction out of 100 that represents each of these categories. In this case, we actually don't know how many entries there are for each of these. We don't know how many shoes there are, how many gloves there are, and so on. We just have the percentages. What fraction in its simplest form of footwear are boots? So we got boots here, 9%. So perhaps the answer is 9 out of 100. And then we simplify that. Oh, we can't simplify that any further. So 9/100ths. But hang on, we need the fraction of footwear. If we do it out of 100, we're also including hats and gloves, which are percentages here and also part of that out of 100. And unless you're a very adventurous dresser, you're unlikely to be wearing gloves or hats on your feet. They aren't footwear. So the footwear are just the boots and the shoes. So could it be 9 out of 63? So how many boots out of how many shoes? But hang on a sec. The boots are also part of the footwear here. So if we're going to do the boots out of all the footwear, we need to do 9% out of 63% plus 9%, because it's the boots out of all footwear, which is boots and shoes, or shoes and boots. So 9 out of 72. What can we do to simplify this? Well, 9 goes into 72. I'll let you think that one through. Or you can do it by dividing by 3, of course, if you want to get there in stages. But we know that 72 is in the 9 times table, and 9 times 8 is 72. So it's going to be, so what are we doing? We're divided by 9 equals 1 out of 8. Okay? And so that is going to be simply our answer here, 1/8. Now looking up here, we can see that boots doesn't look like 1/8 of the whole pie chart, because that would be something like this. But you need to remember, we're finding what fraction of footwear are boots. So we're completely ignoring the gloves and hats. If you had a pie chart that just showed shoes and boots, then this would be showing 1/8 of the pie chart. Okay, onwards to the next. I wish I could say to the people for whom it's not working that if they just go back to my channel, refresh the page and open the video again, they'll probably be able to see this fine. But unfortunately, I don't think they can see this, and that's why they're complaining in the comments. Oh well, you'll all be able to rewatch it afterwards. A group of 48 children are asked to choose their favourite subject from a list of 3. English, mathematics and science. So I hate all of them wasn't an option here. The results are displayed on a pie chart. What fraction of the group chose English? Now we can see that the English section here, I'll zoom in a little bit, has a right angle symbol there. And that means that this is a right angle, a 90-degree angle, a quarter of the whole circle. So what fraction chose English? It's simply a quarter. That's nice and straightforward. If 33 1/3% chose mathematics, work out the angle of the mathematics sector. 33 1/3%? What's that all about? So 33 1/3% is 33 1/3 out of 100. Okay? And you should realise that this is actually equal to 1/3, because 33 1/3 goes into 100 3 times. 33 times 3 is 99, and 1/3 times 3 is 1. Okay, and 99 plus 1 is 100. So 33 1/3 out of 100 is 1/3. We need to work out the angle of the mathematics sector. Now, if we go back to our starting points at the top of this lesson, remember that there are 360 degrees in a circle, not 365. So we need to find 1/3 of 360. It's as straightforward as that. So 1/3 of, remember, of in maths is always times, unless it's out of when it's divided by. 1/3 of 360 is 360 divided by 3. And we can do this really easily in our heads. I can't talk really easily in my head, but hopefully I can do this maths. 1/3 of 300 is 100, and 1/3 of 60 is 20. So 1/3 of 360 is 120. A lot of mental arithmetic is like that, just breaking things down into easy steps. Thank you to the people in the comments who are saying just go back to the channel, reload the page, and you'll find it. Yeah, thank you for the people explaining that to others. Okay, so the angle is 120 watts. So you have to remember that when you're talking about angles, the answer will virtually always, and at 11 plus always, be in degrees. Okay, so you need to remember the little symbol there, which should look a little neater than mine, to make this into 120 degrees. 120 degrees. How many children chose science? Okay, so there is more than one way to do this. One way to do it is to say that a quarter of the children chose English. We know there are 48 overall, so a quarter of, make this a bit smaller so we can see everything as we work this out. Whoopsie daisies. A quarter of 48 equals 12. So that's how many children chose English. And we know that 1/3 of the children, so 1/3 of 48, chose maths. What's 1/3 of 48? You might need to work it out, but it's 16. 16, 32, 48. And so now we know there are 12 and 16, and all the rest chose science. So if we know the total is 48, 48 minus everybody else, 12 plus 16, equals, whoopsie daisies, 48 minus 28, which equals 20. So the answer is 20. There are other ways to do this. You could do it, I think that's the easiest way, but you can also do it starting with fractions. So we know that a quarter chose English and 1/3 chose maths. So what's that all together? So that's one way of doing it. Let's do another one here. So a quarter plus 1/3. I'm sure you're all brilliant at adding fractions. What can we what is the lowest common multiple of 4 and 3? Well, 4 times 3 is 12, and 3 times 4 is 12. Just times in them together gets us there this time. So a quarter is what out of 12? Whoops, not out of 4. A quarter is 3 out of 12, and a third is 4 out of 12. So add these together and we get 7/12. Okay, so what we're saying here is that English and maths make up 7/12 of the circle. So science must be 5/12 of the circle. And then we can find 5/12 of 48. I told you this was a little bit more complicated. So 5/12 of 48. Okay, we can cancel this a bit. 48 is the same as 48 over 1. And if you've watched my video on multiplying and dividing fractions, and if you haven't, why not? If you watch that video, it's one of the short videos on my channel, then you'll know that only when you're multiplying you can cancel diagonally. So 12 and 48, 12 goes into 48, so divided by 12 is 1, divided by 12 is 4, 5 times 4 is 20. So that also gets us to the same answer. You can do it this way if you want to. I think that doing it this way here makes life a lot simpler. On to another kind of pie chart question. I hope you're getting the idea by now that if you have a good understanding of the basic principles, so if you understand about degrees in a circle, you understand about percentages, and you can do some simple work with things like fractions, then there's nothing scary about pie charts. They're quite easy to work with once you're used to it. And the questions I've chosen here, I think, give a pretty broad overview of the different kinds of questions that you might get to do with pie charts. There's not much else, apart from minor variations, that comes up at 11 plus. Touch wood, fingers crossed, anything else I could say. I've said that, you'll probably get an absolute stinker of a question that does something ridiculous with pie charts, but it's relatively unlikely. These are the kinds of questions that keep coming up. Okay, so now this is a different one. We had percentages on a previous question. Now we're given angles in degrees for all but one of the parts of this pie chart, of the slices of this pie. So we need to calculate the value of x. Now we haven't actually been given a number of boys here, and in fact we can see that the value must be an angle in degrees because we're even given the little degrees symbol there. So x is going to be an angle. We know that there are 365 degrees in a circle. 360. Good. I hope I'm training you out of that mistake. It'll save somebody an exam disaster. I bet there's at least one person watching this right now who would make that mistake otherwise. So there were 360 degrees in a circle. So we simply need, of course, to subtract these angles from 360 and then we'll find what's left. So we have to do some slightly boring work with a bit of elbow grease and add these up. So we need to do 76 plus 84 plus 62. Nice thing about adding is you can just stick them all in columns and just do them all together. So that column there, 10 plus 2 is 12, we carry the 1, 7 plus 8 is 15, plus 6 is 21, carried 1, 22. So 2, 2, 2. So 222 degrees is these things added together, not the value of x. Now, you can check that with a bit of common sense. 222 is more than 180 degrees. Remember, 180 degrees is half of a circle, and you can see that this area here, blue, red and green, covers more than half of the circle. So while this pie chart might not be perfectly to scale, we can see that's likely to describe that half of things. We need to find this here, x, 360 degrees in a circle in total. So 360, take away 222, and lo and behold, we just quickly crunch that. So carry the 1, turn that into 5, blah, 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 8, 3, 1, 138 degrees. Now the value of x is really 138 because if you look here, it's x degrees. But I'm going to put degrees in because it certainly wouldn't lose a mark and it just makes things secure, even if in terms of the exact wording of the question you only need to write 138. Blah, blah, blah. Too much coffee before the lesson, making me phlegmy. Right, red is the favourite colour of 126 boys. Okay, creative of them. Well, I can't say anything. It's not my favourite colour, but anyway, I like this t-shirt. I'm so creative in my t-shirt choices. Calculate the number of boys whose favourite colour is green. Okay, now this is probably the hardest question style that you're likely to get for pie charts in an exam. Arathi has written in the comments, lol, I've already done my 11 plus and got the marks. I'm just watching this to thank him very much for all the help. That's a really kind comment, and I really appreciate that you're here, so thank you. And many congratulations on your 11 plus. That's absolutely fantastic that you got the marks you need, and I hope you're very happy at your next school. That's wonderful news. Right, back to maths. So this is, as I said, the hardest question type. This is the bit that you might need to rewind later and re-watch so that you understand it, as long as I explain it clearly enough. Calculate the number of boys whose favourite colour is green. Now we here have got the number of degrees for each part of the diagram. I'm going to clear this so we've got working space. And we know the number of boys who chose red, 126 boys, but we don't know the overall number of boys here. So how can we work this out? There's more than one way to do it, but in my opinion, by far the most straightforward and the easiest to replicate, because you can just use the same method for any such question, is to find how many boys, or how many parts of a boy, are represented by 1 degree. Because then you can just go around the rest of the diagram and do that number times however many degrees there are. I hope that makes sense. So we want the number of boys for each degree in this circle. We know that 84 degrees matches 126 boys, or represents 126 boys. So the number of boys per degree, so we do the number of boys, which is 1, 2, 6, per 84 degrees. Number of boys per number of degrees. Okay, and we want to get that down to per 1 degree. So let's carry on with this. And the easiest way to do this division, when it's possible, is to simplify. Okay, so let's simplify this. What do these both divide by? By far the easiest thing is 2, and I'm really in favour of doing lots of stages of simple cancelling rather than trying to do a big leap, unless the big leap is obvious, because it's pretty quick. So 126 divided by 2 is 63. 84 divided by 2 is 42. Okay, these don't both divide by 2 anymore because one of them is an odd number, of course. Do they divide by 3? Yes, they do. So 63 divided by 3 is 21. I'm always nervous doing this kind of arithmetic in a live lesson because the chance that I'm just going to say something absolutely bonkers and make a terrible basic mistake is always there. Anyway, 42 divided by 3 is 14. How did I get that so quickly? Because I cheated? Well, maybe, no, but there's an easy approach. You know that 45 divided by 3 is 15, I'm sure, and 42 is 3 less, so it's 1 3 less. So if 45 divided by 3 is 15, then 42 divided by 3 must be 14. I'm not sure I explained that so well, but work with me here. 21 divided by 14, well, you can't divide by these both by 2, 3, 5, 7. Aha, they're both in the 7 times table. That's the way to do this. Ask yourself, what times table are both these numbers in? Okay, so 7 goes into 21 3 times, and it goes into 14 2 times. 3 over 2, which is otherwise known as 1.5. Okay, it's worth having both written down, so we've got a bit of flexibility in how we work with this. So we know that it's 1.5 boys per degree. Now this is not the answer to the question. This is what we need to solve the question. But the really useful thing about this is that by finding the number of boys per degree, we've now done most of the working for the other parts of this question, and perhaps even more further down. We'll come to that. So 1.5 boys per degree. Green is 62 degrees. So we just need to do 62 times 1.5. Okay? 62 times 1.5. So the number of degrees multiplied by the number of boys per degree. So you can do it as times 3/2 if you want. That's easier for a multiplication, but times 1.5 is easier, I think, for mental arithmetic, which we can really use here. It's quite simple. Times 1.5, so half of 62 is 31. 62 plus 31, we'll add the 1 on 63, add 30, 93. So it's 93 boys. Okay, it's as easy as that once we've got this stuff here all worked out. I seem to have got loys per degree. It's a B, but written in my feeble handwriting. Yellow. Again, 1.5 boys per degree. Yellow is 138 degrees. We've already worked that out here. So 138 times 1.5. Let's do this using 3/2 instead. So 138 times 3/2. I've chosen 3/2 because that means I can do a proper fractions multiplication more easily, for reasons that will become apparent. So again, when you're multiplying, you can cancel diagonally. So this can be divided by 2 because it's an even number. 1, divide this by 2. Well, 130 divided by 2 is 65. 8 divided by 2 is 4. 65 plus 4 is 69. So that's going to give us 69 times 3. You could do this as a multiplication over here. But let's do a bit of mental arithmetic just for practice. 60 times 3 is 180. 9 times 3 is 27. 180 plus 27 is 207. Hope I got that right. So this should be 207 boys whose favourite colour is yellow. Not blue. Okay. Well, do we know how many are blue? We don't yet, we haven't worked that out. So there are 2 ways to do this. One way is to find out how many boys chose blue as their favourite colour. Okay, and then work out the overall total and subtract it. A simpler approach at this point would just be to work out all the other sections and add them together. So we got red is 126 boys, green is 93 boys, and yellow is 207 boys. So if you add those together, you'll have the number of boys who chose not blue. So we have to do 126 plus 93 plus 207. So 126 plus 93 plus 207. Behold my handwriting, ye mighty in despair. 10, 16, 9, 10, 11, 12, 2, 3, 4. So 426. So we've just added up all the other sections. Calculate the total number of boys. Well, there's more than one way to do this. So you could simply, you have the total number who chose not blue colours. You could calculate the number for blue, 76 times 1.5, and you could add them together. That would work fine. I'm sure that makes sense. It's quite simple. There's another way to do it though, which I think is a little bit more elegant. We know that it's 1.5 times the number of degrees to get the number of boys. Does that make sense? In the circle, there are 360 degrees in total. Times it by 1.5. 360 times 1.5 equals 360 plus half of 360. We know that's 180 degrees. 360 plus 180 equals 540. So the answer is there are 540 boys in total. Just to recap that so it makes sense, we've already worked out up here, under our green heading here, that each degree in the circle represents 1.5 boys. When we need to find the total, we're dealing with the whole circle. Okay? 360 degrees. So you just follow the same procedure. Times 360 degrees by 1.5, and you're golden. You can also do it, as I said, by working out each part of the circle. There's only one missing, and adding them all together. And that's it. Goodness me, we've made it. That was relatively short and sweet for one of my live lessons here. So let's push on to this week's So I want to talk about reading this week because I haven't for a little while, and because this has been all very maths focused. I think there are two bits of advice that people are given, both of which are good advice, but which can seem to contradict each other. And one bit of advice you hear often is people say you should read very widely, and you should read in a way that challenges you and builds your vocabulary and develops your comprehension and your ability to think about texts in a grown-up way. And the other bit of advice, which to be honest isn't a bit of advice that I have shared myself in the past, is read things you enjoy. Because if you read books that you don't enjoy, you probably won't learn anything useful from them, and it's much better to focus on the books you enjoy and try and get as much as you can from them, rather than constantly trying to read Dickens, Dostoevsky and getting lost. But I want to suggest that there is a middle ground between these things. Rather than just reading things that challenge you and that you hate, and reading books that you really enjoy but that don't much challenge you. Try to look for ways to develop your reading based on the things that interest you, but taking that into things that are slightly more challenging and that might make you think about things in a new way. So, for example, if you really enjoy reading Harry Potter books, have you thought about looking into some slightly more grown-up fantasy and magic writing? Have you looked, to take the most obvious example, have you looked at Tolkien? If you've read The Hobbit and you enjoyed it, have you considered looking at some of his other books, perhaps even The Lord of the Rings, if you're very adventurous, although that is a more adult book, and so on and so forth. If you enjoy spy fiction, like the Alex Rider series, have you then considered looking at some spy fiction that's written for adults, or at least for teenagers? To see whether that might be something that interests you. Have you considered looking at some classic spy fiction, like the John Buchan books, for example? So try and find things that challenge you more by taking the things that you like and developing them into new areas. And this way you can get the best of both worlds. You can read things that are a bit more challenging and mature. You can also encounter some classic books, but you can stay in the territory of things that already interest you, so that reading and expanding your reading isn't a chore. Right, okay. And now it's time, of course, to take Okay, my comments here have gone absolutely bonkers. So let's see what I've got here. Okay. Great. Safia wonders how to write instructional writing. I bet you're preparing for the CSSE exam in Essex, because that's the only exam I can think of. Just checking my maths answers away. That's the only exam I can think of that does set instructional writing, and it is a pretty weird skill. I'm not going to give a lesson on it now. It's something that I might actually consider doing in this channel because I think it would be useful. But I think the one thing I would say is that you need to describe what needs to be done very, very precisely. So, for example, a classic one would be changing a light bulb, to give an obvious example. And you might be tempted to say something in one of your instructional steps, like put the bulb into the light fitting. But a good answer might say something like, carefully insert the bulb into the fitting, being careful not to squeeze the glass too hard, and then rotate it gently in a clockwise direction, stopping when you encounter resistance. Can you see the difference between that and put the bulb in the light fitting? So I've described it really precisely, showing exactly what to do and including some understanding of what you might not want to do. And in being so precise, I've also used some good vocabulary like resistance and rotate and clockwise and that kind of thing. But I haven't done anything too outlandishly difficult. So that thought process is basically what it's testing. And I think there's one thing to go there, it's be really precise about your instructions and find the best words that come naturally while being precise. Don't try to come up with fancy words just for the sake of it, because then your writing will be less precise and more confusing. Great question, thank you. What other questions do I have here? Hud says, I've read over 1,000 pages books. Even if I think it's boring, I still read them, Robert, sir. Sir. No, it's very respectful and thank you, so I shouldn't be making fun. But I'm just not sure I'm worthy of that level of respect. I think it's wonderful that you're such a dedicated reader. I'm about to give some terrible advice here that all parents and teachers will hate me for. I used to be really obsessed with finishing books that I started and thinking that, if a book was something that people said I should read, then I should read it and I should read it to the end. I've really changed my view as I've got older, and I'm terribly old. No, I've got some grey hairs. I guess I got some claim to being old. I really take the view that if I start a book and if after, 30, 40, 50 pages, I'm not enjoying it, then I tend to give up on it because life is too short. There are so many books out there. There are far more great books that I could read than I will ever have time to read. So I'd much rather give up on a book that doesn't do it for me and move on to another one that perhaps does. And that might be a 1,000-page book, but don't torture yourself forcing yourself through massive books that you aren't enjoying. That's not what life is for. It really isn't. Unless it's a book that your teachers or tutors or parents have told you to read because you must do it for your work or whatever, then of course you must read it. Right. Okay, what else have we got here? What book should I read for my 11 plus? That's too massive a question. There aren't any books you must read for your 11. There aren't any books you should read. The important thing is to read a range of books that, as I said, combine interest and a bit of challenge, and to think about them properly as you read them, because how you read is far more useful than what you read for your 11 plus and for your learning in general. So think about, what is the author doing? How are they making this book exciting and interesting? What is it about these characters that makes me want to keep reading? What imagery do they use and why does it matter? How do they structure their sentences even? How is the plot put together? If you read even the most rubbish book, but you're thinking about it in those terms, you'll learn a lot. What books you should read, you'll find your own way. Explore. What is your favourite subject? It's whatever I'm teaching today. My favourite subject is pie charts. Robert, your books are amazing. Thank you very much. I don't know why I picked that one to read out. Thank you. I really appreciate that. If we don't get into a grammar school, will it affect us when we're older? That's a really difficult question to answer. Look, on one level, obviously I can't say it won't affect you at all when you're older, because if it really doesn't affect anyone, then what's the point of trying to get into a grammar school? What's the point of these exams? If I said it didn't matter at all, I'd be pretty much telling you not to watch this channel. Any great opportunity can matter. It can be a real help. It can give you a leg up in life. However, I think what I say all the time to people is still true, that if you're the kind of person who's working this hard to prepare for your exams, you're watching these videos, you're doing lots of homework, you're really thinking about becoming better at all these skills, and then you go into the exam and it goes wrong, first of all, you've still got all those skills to take with you into your secondary school, and secondly, you've already proved that you're the kind of person who will do well at any school that you end up at. And your life will probably be a great success because you're that kind of person, whatever school you go to. So I think both are true. Grammar school is a great opportunity. If it's a good grammar school, that's a fantastic thing to do, although there are many great schools that aren't grammar schools. But if you don't get into the school that you want, you're the kind of person who's likely to make a success of life anyway. So don't worry about it. Just move on, get on with your life. Try to enjoy it, because fundamentally, what better thing is there to do with it? What else have you got here? I've got some very specific questions about kind of questions, how to do conversion questions. I will cover that at some point, but I'm not going to answer it now. Please don't spam this. I've got squizillions of questions. Did you go to Christ Hospital? Yes, I did go to Christ Hospital. I was a student there, and then I was also a history teacher there for a bit, so it's a place that I know extremely well. How much books should you read in 1 month? You mean how many books? Because you're talking about a discrete number. How much water? How many books? Well, if you read 1 book and you think about it profoundly and learn lots, then that's plenty. It isn't about the number of books that you read, it's about what you get from it. I'm particularly aware of that because I'm someone who really forgets a huge proportion of what they read. I don't have a very retentive memory. And so I can just read something and then lose everything useful from it apart from some overall impressions. So I'm aware that if I just read loads of books, all it gives me is the ability to say that I've read them, which I don't care about at all. So I'd prefer to read slowly and really get something from those books. In depth, what is a multiple choice question? It's a question that gives you multiple choices. I don't know how much more depth to go into, but I've got lots of videos about them on this channel. Just look around. I'm being repeatedly asked in consecutive lessons, what does the S in RSL mean? That's for me to know and you to guess. Can you do GCSE exam? Well, I couldn't do a GCSE exam in Japanese. I probably could do GCSE exam in some other subjects. I won't be teaching them on this channel because this is an 11 plus channel. Okay, I think that we are running to the end of new questions here for me to answer. Ingrid Meyer or Mejia says, can you say my name? I don't know. I gave 3 attempts there. You tell me. Okay. I think that will do. This has been a slightly shorter lesson than sometimes. It's still been 3/4 of an hour. Don't complain. But it's been a real pleasure. Thank you for your questions. I'm sorry about the technical issues at the beginning, but thank you all for hanging on. And I hope to see you next Tuesday evening at 6 o'clock for my next Easy 11 Plus live lesson. In the meantime, please subscribe to this channel. Have a look at the links in the video description. You'll see there's a link for getting lots of free papers and detailed solutions and example answers and all that kind of stuff completely for free. So click on that by all means. And that will do for now. See you next time. Thanks a lot. Bye.